Hello, my friend. Recently, I prepared an interesting study. I managed to collect a small collection of the most accurate bubble ampoules. These ampoules are used in such measuring devices. This is something that comes in handy if you're dealing with a machine tool linear motion coupler repair tool. They can be used to effectively monitor the condition of metalworking machines as well as the surfaces plates and the straight edges. I have already somehow created a device using such a bubble ampoule. Here is a link to the video. I have a Chinese ampoule, a Soviet ampoule and an English ampoule. Sensitivity of 1 division on the ampoule scale. Ampoules are tied to the center of mass of our planet. Other planets, primarily the Moon, have a certain influence, but this influence is insignificant and does not harm the measurement result. When we create a plane following the ampoule, we create a sphere whose radius is equal to the radius of the Earth. Therefore, on a distance of 100 kilometers, the height of the sphere is 196 meters. On 1 kilometer, it is almost 20 millimeters. And on the meters, only 2/100ths of a micron. For our tool, this is an absolutely small value. Therefore, we can consider a sphere with a gigantic radius created by such a level as an ideal plane within 1 or several meters. I give the calculation formula. The ampoule works due to the precise shape of the sphere inside. Creating such a sphere is not as difficult as it seems at first glance. I invented my own version of the manufacturing technology of the inner surface of the ampoule, due to robbing of the rotating ampoule from the middle, using a support sphere of the desired convexity to direct the internal lapping. Anyone familiar with the technology of manufacturing lenses and mirrors for telescopes knows that it is quite possible to make such a convex sphere. If anyone knows how such precise ampoules are made in industry, please provide information. On all these ampoules, the distance between the scale divisions is 2 millimeters. Its sensitivity depends on the radius of the sphere in the middle of the ampoule. An ampoule with a sensitivity of 100 of a millimeter per meter has a sphere with a radius of 200 meters inside. Next, you can see how the diameter of the sphere and the sensitivity of the ampoule are related. This stunt will give me the opportunity to test their actual accuracy. I will also see the features of their practical work. In the room I chose the most protected place from thermal fluctuations, because they have a bad effect on accuracy of results. Such a stand is designed to accommodate a meter-long straight edge, which will be keynote of our device for testing ampoules. Granite blocks are glued together and glued to the concrete floor. Everything should be static. The meter-long straight edge on the left side rests on the hinge. The integrity of the left edge of the straight edge in height is controlled by micron microcatheter. The right edge rises or falls as it rests on a microlift. The flexible support of the movable right edge of the straight edge protects the microlift from lateral backlash. I also control the height of the position of the right edge of the straight edge moving on the microlift with a micron or 100 nanometer microcatheter. In this way, I can raise or lower the right edge of the straight edge, which is a meter long, by 1 or 10 microns, while the left edge does not move, and watch how the bubbles of my ampoules react to this action. I try to keep the heat from my body or the video camera as minimal as possible to the stand and ampoules. In addition, I am on an additional floor that is attached to the ceiling. In this way, the weight of my body does not affect the floor. Ampoules are fixed with plasticine. This makes it difficult to adjust their position, but this is not critical. Then such a solution simplifies the implementation of this project. One English, Soviet, and Chinese ampoules are installed on a straight edge. Another Soviet one is installed nearby, but on a non-moving base, as a control. For better visibility, I put white paper under the ampoules. The camera is fixed using thermal insulation, because its battery gets hot. If possible, I protect the stand from the heat of my body with warm clothes. A heat screen is also installed between me and the stand. To shoot further material, I go to my studio at 5 o'clock in the morning. It would be better an hour earlier, but the curfew is until 5. The sun is still below the horizon, and I have about an hour for K shots. Soon you will see the result of this work. Now I will raise and then lower the right edge 10 times by 10 microns in one step. I've edited the video to make it easier for you to watch, but it's a single video series.
Плюс 10 мікрон.
10. Досить точно. 15 секунд. 15 пройшло. 20. 20 секунд. 25. 30 секунд.
Плюс 10 мікрон.
10. Досить точно. 15 пройшло. 20. 25. Підходить 30.
Єсть.
Плюс 10.
10 мікрон.
Досить точно. First in real time, then accelerated by 7 times. Мінус 10.
Мінус 10 мікрон.
Майже точно. Можливо і точно, точно.
Пункт.
Можливо і точно. На зниження. 15 секунд. 20. On the graph we observe some instability, as if the bubble sometimes stacks.
Плюс.
This was most evident on the ampoule from the USSR. The following experiment is the same, but one ampoule is turned approximately 45 degrees.
Чекаю ще 15 секунд.
This is to make sure that the ampoule works adequately both in one and in another position.
30.
In addition, we will see how the sticking of the bubble will show itself during the second pass.
Плюс 10. 30. Мінус 10. Ніби точно.
We also see that the readings of the scales on the ampoules do not exactly correspond to their real movements.
Йдемо зараз на плюс ще один раз.
The second pass shows this result. Now the step will be 1 micron.
Плюс 1 мікрон. Десятка в плюсі. Це перший мікрон на плюс. Підходить час. Плюс 1 мікрон.
In the process of watching the video, new information will appear from the audience, and I will respond to it in the description of this video. Since after publication I can supplement the video only in the description of it.
Підходить час 30 секунд. Плюс 1 мікрон. Точно. Зараз третій мікрон в плюсі по шкалі. 15 секунд пройшло. Поставив точно. Це самий нульовий. На шкалі мінус 4 мікрон. 25 секунд. 30 секунд.
Now I will raise and then lower the right edge by just 1 micron.
Час 30 плюс мікрон. Дві десятки в плюсі. Англійська прям стала з моєї...
I see such a movement on an ampoule with a sensitivity of 200 per meter. And on ampoule with a sensitivity of 100 per meter, I see such a movement quite confidently.
Мінус мікрон. Дві десятки в плюсі. О, англійська явно пішла в сторону. Явно. Зроблю для забави знову плюс мікрон. Ну, три десятки в плюсі. О, англійська явно стала по нулям. Прямо явно по нулям. Вона чудово бачить мікрон. Чудово. Підходить час. Іду знову на зниження. Мінус мікрон. Дві, а то й 2,5 десятки в плюсі. 2, а то й 2,5. Чудово англійська працює.
Using an ampoule with a sensitivity of 100th of a millimeter per meter, 1 micron can be reliably monitored on a meter per meter surface plate. I improved on my last project and plan to make a bubble level like this. Preliminary adjustment and fine adjustment. Using such a level in a complex with a special stand, it will be possible to produce an extremely accurate surface plate and straight edge. At a distance of 1 meter, the error will be less than a micron. I want to devote more time to you, my viewers. I can create a lot of interesting original material for you. I want to show in detail how to create really accurate machines for your workshop with minimal financial outlay. I already have several sponsors on Patreon. I am very grateful to them. Maybe you want to help me grow my YouTube channel. When there are more sponsors, I will be able not to be distracted in order to earn a living. Then I can work for you all the time. Thank you. Goodbye.